I'm back again, guys. Here it is, the physics section of May 2014 Higher Tier Unit 1. This is for my Year 10s. This is for my resitting Year 11s, okay? As always, I'm incredibly excited about this, okay? You know what? Yesterday, Wales lost at rugby, and so I thought, what can I do today to cheer myself up? And then it came to me, I can do another video for you lot. So here it is, physics. Let's get going. So, straight into the electromagnetic spectrum. If you see the electromagnetic spectrum and you are not singing the electromagnetic spectrum song, then you need to check it out on YouTube, okay? Your science teacher should have showed it you. I know my class has heard it about 1,000,000 times. I'm not going to sing it for you right now, but just look it up, okay? The electromagnetic spectrum song, and it's got a load of good information. Funnily enough, though, it's not going to help you with this question, but normally it would, okay? So, straight into it. The electromagnetic waves are transverse waves. Look at the diagram, or part of the electromagnetic spectrum. Okay, so you've got radio, microwave, infrared, visible light, and ultraviolet. You can sing that bit, it's fine. Okay, what does the direction of the arrow labelled A show? Okay, so we've got a nice little choice of different things that we could put. The only correct answer, however, is increasing wavelength. Okay? Part B. What does the direction of the arrow labelled B show? So look at the B, pointing in the opposite direction. So what is it going to be? It's increasing energy. Really quick start to the question, okay? Again, with these multiple choice questions, if you don't know the answer, put a guess in. Just have a go, yeah? They're not going to penalise you for putting the wrong answer, so you might as well. It's a 1 in 4 chance of getting something right, okay? If you know the right answer, obviously, happy days. So, next page, here it is. Radio waves can have different frequencies and wavelengths. What is meant by the frequency of a wave? Another fairly straightforward question. We should be thinking it's the number of complete waves per second. You might be thinking, good, I know that. Can you remember what they're measured in? That's not part of this question, but can you remember? You should remember they're measured in hertz. Waves per second, all right? Here we go. So now it gives us a little bit of information about the different radio waves. We've got extremely low frequency waves, all the way up to very high frequency waves, okay? Now, calculate the wave speed of ultra low frequency radio waves. So there's 2 ways to attack this question. First way is just being a brain box like me, okay? If you can remember the speed that the electromagnetic spectrum travels at, so what the speed of light is, all those waves travel at the same speed. So if you just put 3 times 10 to the 8 meters per second, then you get 2 marks straight off the bat. If you're not quite as good as that, when you turn to the front cover of your test paper, there's that equation page. On that equation page, it actually tells you how to work out wave speed. So wave speed is equal to frequency, I'll just put in as F, multiplied by wavelength. You guessed it, WL. So if we have a little look, 3 multiplied by 1 times 10 to the 8, you should know, obviously, the 3 times 1 is just going to be 3. You can leave 10 to the 8 as it is, so it's 3 times 10 to the 8, okay? And that's it, meters per second. There's your 2 marks, okay? A little bit tricky, but again, if you remember the speed of light, or you just work your way through it, you can get 2 fairly straightforward marks. Last question on this page is, how do the data in the table show that these different radio waves all travel at the same speed? So what they're looking for here is obviously as your frequency, this column here, is increasing, your wavelength is decreasing by the same amount. That means it stays the same. So what they're looking for here, for your 1 mark is that as frequency decreases, wavelength increases by the same amount. Okay, really important. Okay, same amount. It has to be by the same amount. Okay, here it comes. 6-mark question. It's a bit of a beast, but we're going to have a little look at it. Just like usual, I'll talk you through the question. You can pause me, take 5 minutes to have a little look through the 6-mark question, like have a think about what you would write about, and then I'll talk you through the mark scheme for it as well. Okay, so we've got 2 people, Anton and Ben. They like to sunbathe. Okay, so Anton has fair skin, so obviously quite pale. His skin burns after 5 minutes without sunscreen. Ben has dark skin. His skin burns after 20 minutes without sunscreen. Anton and Ben want to sunbathe for 180 minutes. They do not want their skin to burn. They have 2 different sunscreens. Okay, so they've got bronzer and top tan. Sun protection factor, SPF, of 15 and 45 respectively. Okay, they choose one of the sunscreens and apply it only once before sunbathing. Ben can use either bronzer or top tan. Anton must use top tan. Explain why Ben can use either bronzer or top tan, but Anton must use top tan. Use information about the sunscreens and their skin types in your answer. Right, so like I said, he's a bit of a beast, but let's have a little look at what we need to do. Like always, these 6 markers, you can break them down a little bit, okay? So explain why Ben can use either bronzer or top tan, but Anton must use top tan, okay? So that's the main part of this, this question. But what it tells you next is like where we can break it down a bit. Use information about the sunscreen. So we know we have to talk about the sunscreens, but we also have to talk about their skin types as well. So if you talk about both of them, then we start getting into the really, really good marks. Okay, so pause me now and have 5 minutes just to write down some notes. So pause me now. I hope you paused me. I hope you've got some notes. Let's have a little look at the mark scheme, shall we? So here it is, the mark scheme. Let's zoom in on the levels to start with, like we always do. Now to get level 3 and to get those full 5 to 6 marks, then you need to make 1 correct calculation and you need to explain why dark skin allows longer safe time in the sun. So let's cover the calculations first. So it tells you the answers here, but it doesn't tell you how to work it out. So let me talk to you a little bit about it. So Anton's safe time with bronzer is 75 minutes. You might be wondering, how the hell have they figured that out? So what you need to do, okay, so it told you that Anton will burn after 5 minutes in the sun, okay? It also tells us that bronzer is a SPF 15. So if we take 5 minutes and multiply by 15, that means that he can spend 75 minutes in the sun. It then, obviously, well, that's one calculation, but you can do it the other way as well. So top tan, sorry, that should be a highlighter. Top tan, 225 minutes. That's because, again, it takes 5 minutes for him to burn in the sun. You multiply it by the SPF for top tan, which is 45. And then that gives us 225 minutes. You could do exactly the same with Ben. Okay, so Ben doesn't burn till 20 minutes. And so if you put 20 in instead of the 5, so just put a 20 by here, and then multiply it by the 15, it means that it gives him 300 minutes, whereas then if we put 20 times it by the 45, would give him 900 minutes to stay in the sun. Okay, brilliant. So the explanation for this, you might notice that in the top bit it says, to reach level 3, so this bit here, to reach level 3, answers must refer to the pigment or melanin, okay? So we should remember this because in year 9 you did, is it safe to spend time in the sun work? So you might remember it. Obviously you should have covered it a little bit in year 10 as well anyway. So the explanation is that dark skin contains more pigment, okay? Or dark skin contains more melanin, okay? So therefore, the pigment or melanin absorbs UV, or you could also have pigment or melanin stops UV, okay? So just the fact that because you've got more pigment in your skin, then it stops more of the UV, and so you get less likely to get burnt. All right? That, although from the outset looked like quite a tricky 6-mark question, I'm sure you'll agree, now that I've talked through it, it's actually not that bad. And so there's some really easy marks available here. For a level 2 answer, so 3 to 4 marks, you're looking at doing this bit up here, or doing a little explanation. So if you like, I can't do the equation bit, but you can do the explanation, you still can get 3 to 4 marks. So as long as you have a little go at this, the worst thing you can do with the 6 markers is not answer at all, because loads of people do that. You get 0 automatically if there's nothing down. But if you just have a go, I mean, God, level 1 identifies differences in skin colour as important. If you just said dark skin does not burn as much as light skin or fair skin, then you're in the level 1 category. You're picking up 1 or 2 marks. So please don't be lazy. Please don't ignore the 6 markers, because they are worth vital marks, all right? So keep your eyes open for them, please. Okay, 3 pages left to get this physics section done. Melissa has 2 identical radiators. One contains water and the other contains oil, okay? So the contents of the radiator, 25 kilograms of water, 25 kilograms of oil, power of electric heater in the radiator, all right? So they're trying to complicate things. All we want to know is what they're telling us about, okay? So the heater in the water radiator supplies 3,150,000 joules of energy to the water. The specific heat capacity of water is 4,200 joules per kilogram. The initial temperature of the water is 20 degrees. Use a calculation to predict the temperature rise of the water, okay? So easiest way to do this, okay? So you've got to think about the energy going in is 3,150,000, okay? There it is. But we're dividing that across 25 kilograms of water, okay? And we know that it takes 4,200 joules of energy to heat up 1 kilogram of water. So if we divide it by 25, which is the mass of water that we've got, multiplied by the energy required to heat up 1 kilogram, so we divide it by the energy required to heat up 25 kilograms of water by 1 degree. So if we have a little look, we've got 3,150,000 divided by 105,000. Okay? So now we know that we've got up here is the energy input. Down here is the energy needed to heat 25 kilograms of water up by 1 degree. And if we press equals on our calculator, we end up with 30. So the temperature rise is 30 degrees C. Okay? Again, quite a complicated one, that. Quite hard to get your head around. If you need any more help, obviously come see me, and we can have a little chat about it. On we go. So, the temperature inside the radiator does not actually rise by this amount. Explain why. So now we've got to start thinking about efficiency and what's going on, okay? So to get our 2 marks, we need to basically explain where that energy is going. So either you can say that the energy is being used to heat the radiator, or you can say the energy is being used to heat the room, okay? If you say the energy is used to heat the room, you get 1 mark. If you say the energy is being used to, is radiated to the room, then you get your 2 marks. Same for when you're talking about the actual the radiator itself. So if you say energy is used to heat the radiator, you only get 1 mark. But to get to that 2nd mark, you need to say that energy is conducted to the radiator. So we're taking energy out of that liquid and we're putting it somewhere else. Okay, remember, energy can't be used or destroyed. It just moves and changes form. 2 more pages, still on specific heat capacity. So the specific heat capacity of water is 4,200 joules per kilogram. The specific heat capacity of oil is 1,670 joules per kilogram per degree C. Melissa thinks that the radiator filled with oil is the best. Her reasons are: A, it will heat up quickly when it's switched on. B, it will cool down slowly when it is switched off. One of her reasons is not correct. Which reason is not correct? So you either get this or not, but she's correct with A, and so the one that's incorrect is B. It will not cool down slowly when switched off because it has a lower specific heat capacity. It will cool quicker. Just like it'll heat up quicker, it will cool quicker. It's better because it heats up quicker, but it still cools down quicker. Okay? Last mark for this page. Why would the radiator be more useful if it heats up quickly and cools down slowly? So think about it. Why would a radiator be more useful if it heats up quick, cools down slow? Easy mark here, guys. So you could say that the room would stay hotter for longer, or it would heat up quicker. You could say that the radiator continued to keep the room warm for longer afterwards. Okay, so the room would heat up quicker would probably be the easiest one. On we go to the next page. Right, Sanjay uses infrared remote controls for his TV, DVD player and CD player. The remote controls for the TV does not work for the CD player or for the DVD player. What type of infrared signal is used, and why does this remote control only operate the TV? So you should remember that the TV uses digital signals. Okay, so that answers the first for 1 mark. The second mark is for saying that there are different signals. For the different devices. Okay, move it on. Sanjay is worried about the harmful effects of infrared radiation from his remote controls. He searches the internet and finds the following. So, infrared is not as harmful as ultraviolet. Doctors use infrared lamps to treat sore muscles. Industry uses infrared ovens to dry paint, paper and leather. Spacecraft have gold film on the windows to reflect infrared rays from the sun. This is very expensive, but it protects astronauts. Okay, explain why these statements do not provide scientific reasons to stop Sanjay worrying. Okay, this is a really open question, right? They're trying to scare you off with a load of reading, but it's a really open question. You could have anything from there's no data, so there's no proof that they've taken any tests with it. The websites may be unreliable. I'm not going to write them all down, but there's no information about remote controls on there because it's all about different things. There's not as harmful statement. It's not very accurate or precise. There's no mention of wavelength or frequency of the infrared radiation. There's loads of reasons that you would that this isn't going to help him out. Okay, so just have a think. 2 things. That's all you got to put down. Loads and loads of different reasons. Let's move it on. Last page. Here it comes. Right, optical fibres are used for communication. Light travels along an optical fibre by total internal reflection from the sides of the fibre. Older TV and internet cables are being replaced by optical fibres. Describe the advantages of using optical fibres for TV and internet signals. So there's 2 big reasons here. Yeah, you should remember them from class. First and foremost, if you're using optical fibres, light is one of the fastest things, is the fastest thing that we know, okay? So it's obviously going to be faster. Also, if you put down multiplexing, then you get your second mark. Multiplexing is where you get loads of signals into the same fibre, okay? You can get thousands of different pieces of information into one single optical fibre by multiplexing, all right? So it's lots faster. You've got multiplexing. There's a couple of others. You could have less or no interference. You could have more information can be transmitted. Less signal loss or no signal loss. So there's loads of different options in there. Again, you've just got to write down something. All right. Now this concludes our higher tier physics unit 1 paper. I hope it's been useful as always. If you've got any feedback, please just come let me know, and obviously I can try and change it up to make it better. Enjoy the rest of your weekend, guys, and remember, stay classy.